How dare you keep
I know. Okay, so actually our warm-up question is pretty similar to what we just did as our homework quiz. So again, trying to remember those properties of parallelograms. So again, going off of what Mia did on the last one, hopefully you guys can realize we're going to set these two equal to each other. So the opposite sides should be equal. So I'm able to set that equal to each other. So that's almost identical to what we did on the homework quiz. Okay, we can do the same thing for the y then as well, the two sides on the opposite sides there. 7y, right, you see, yeah. It would go 15 over there. So the biggest thing is noticing the difference between sides and angles. Angles are typically inside if they can fit them in there. Sides are typically on the outside. They try to put a little degree measure. Sometimes I forget it if I'm drawing the picture. You'll see that a lot. So we found x and y. And then again, our a and b, hopefully, this is probably a little bit trickier, because if I try to do a plus b equals 180, I'm going to be kind of stuck, because that's two variables. So does anyone have a different strategy? Philip, what did you do? Did you figure out a and b? Very good. Yeah, so he noticed that we can look at those two. Typically, we go horizontally, just because that's the last two problems that work that way. We're going to go this way now. Those two together should add up to 180. Girls, can you close up your computers, please? Thanks. So we're going to add those up to equal 180. So again, I wouldn't want to include the b quite yet. We'll deal with b in a second. We're going to move that 10 over. And then we'll divide by 2. And we end up with A being 95. So that's this angle here. Now that we know A is 95, now we can kind of use that horizontal rule that the two angles that are next to each other should add up to 180. So now we're going to go this way. So then that would allow us to find our B. That makes sense? Okay, okay, thanks, Mia. Keeping me honest, huh? All right. So, yeah, so what we're doing today is going to feel a lot like yesterday. And actually, I just realized the first half of this we did yesterday. Do you guys see that? Those problems we did last class.
Oh, yeah.
I know you're going to be hard, but our notes going to be a little bit shorter today. Okay, flip it over. Holy cow, lucky ducks. Yeah, we did that yesterday. I must not have looked at this, but in the past I might not have fit that in the previous day. So we're going to go just to the back side. There's a lot of writing on the back side, so we'll still get, don't worry, we'll still get enough to do. There's enough writing we can do on the back side here. So flip that over. Okay, so basically what we're doing today is the opposite of yesterday. So yesterday we said, hey, here's a parallelogram, here are all of its properties. Now we're trying to do the opposite. So now we're trying to say, I don't know if it's a parallelogram, how can I tell? And so we're going to write down some rules that are enough information to know that for sure something is a parallelogram. And so a lot of them are the rules we learned yesterday. So if you see this, we don't need all 5 things. We can use any of these 5 or enough. And so we'll talk about that. So we can show, so it says ways to prove a quadrilateral is a parallelogram. Any of the following are enough.
So if we have just one.
Yep, just one of these is going to be enough to say, yep, it's for sure. Kind of like a little parallelogram DNA test. The DNA says it's a parallelogram. These are right. I know. You know.
Keep going.
Yeah.
I had fun. What do we get to make a little keychain? The little thingy with the spit. What?
Yeah, you end up with a vial of like spit or sweat. I think it is.
No, I think it was fun. You were literally showing it to me last year.
Okay, let's focus. All right.
All it is spit.
I was gonna say I did not have anything to do with
Because it had like the little thing on it, and then there was like a little thing, it was green. And it was like on this paper, and then you were like showing it.
I'm not sure.
How weird.
Okay, I'm sorry. It's
This is all your fault.
okay.
Okay. So my question for you guys, my first rule, and we talked about this yesterday, that has both pairs of opposite sides are parallel. How could I show that sides are parallel in a shape? How do I know two sides are parallel or two lines in general are parallel?
They have little arrows.
They have the little arrows, that'd be great, but what if they don't have the little arrows? What if they're just two lines or and maybe the hint is maybe they're on graph paper? How could I know lines are parallel? They never intersect, but there's some like a mathematical way to check why they're parallel.
Yeah. I got you.
I don't think they know.
Wait.
Oh. Difference, or sorry, same slope. Yep, that's exactly what I wanted. So you're gonna check their slopes. They never intersect, but we wouldn't want to just say, hey, they look parallel, it looks like, so we want to check their slopes. Okay. So we're going to actually have to do that math, or if they give us the slope, we'd be able to use that. So the same slope is what we're looking for in that case. All right. Another one here. It says our next one, we talked about both sets of sides are equal. So opposite sides are equal.
How do you write your P?
My P?
Your P. No, but like, write it. Write it. Okay, wait.
I'm about to write P.
You do the little center.
This is maybe why I put you in the back of the room.
Oh, okay. Yeah, I see how it is.
So kind of trying to check to see if they'd be equal. I mean, I'm probably not going to ask you to do this because this would be a big pain. That'd be maybe like the distance formula.
I don't remember that.
We did it last chapter. That was the big.
I do.
Yeah. But sometimes you're going to just be able to tell that they're the same length if they like are on a coordinate system, or just know the length.
You just gotta know.
Yeah.
Those who know.
I'm just gonna know about
I would probably hope we could use the slope instead because slope is a little bit easier. Okay. And again, these are all properties we learned yesterday.
my ears itching for another piercing.
Those who know.
This one might be, again, another one that's kind of tough to show, but if they give you that information or you have enough information to come up with, be able to show that the opposite angles are equal. Now, if they just mark those for you, you can say, yep, this is definitely a parallelogram because of this rule. And I don't need a ton of detail with that, just kind of the idea. The next one is another one that we learned yesterday. The diagonals bisect each other. Remember yesterday we checked the midpoints. So they should have the same midpoint in the middle there. That was a really bad drawing. Diagonal got a little wonky there. And then the last one is one that, like, I would never think of as a student. Like, I wouldn't be like, oh yeah, that's obvious now this is a parallelogram. This is the only one that I think is kind of strange that that's enough information. So this last one, we didn't really talk about this yesterday because this would not be something that you would know is a way to prove it, is if you show that we have one set of parallel sides, but they also have to be congruent. So if you have one set of parallel congruent sides, it automatically has to be a parallelogram. That's so crazy. In my mind, that like kind of blows my mind because like I feel like I don't know how you would know that from that. And there is a lot of reasons why that is, like geometrically, but I'm not going to get into a ton of detail because I don't think it's super, like I don't think you'll be like, oh yeah, that totally makes sense now. I think it's just a rule that we'll trust at this point, okay? But that is definitely a way we can use. So if they give you that information, it's okay to say it's a parallelogram. So what we're doing for our homework here, or not our homework, sorry, this last question, is we're going to put this on the graph paper today, and then we're going to determine which of these rules would be a smart one to use to be able to prove that it actually is a parallelogram. So I would start by putting that on the graph paper, if you want to do that as well.
Almost.
Sorry.
Do you have to do two set of homework or just one?
I don't, we'll change it. Your graph paper.
Check the slopes.
Yeah, and so start thinking about how you guys could maybe use one of these rules and what did you try? Try to figure out how you would show me that's a parallelogram. So I'll give you guys a few minutes to look at that and see if you can figure that out. So one of those 5 rules could be used here. I'll work with you guys in a second on it. All right, are we good? Does anyone still have more time? You're good, Link?
I am. It just took a minute, okay?
Okay.
I shouldn't have done anything. Other than that, yes.
I love the reflection of the word. Okay. All right. So, what did you guys try? A lot. Yes, what did you try? Slope formula. Yeah, in slope formula, you can use the actual formula. You can also just do rise over run. I think that's what I see, like looking over quickly at Link's and Dylan's. They kind of just did rise over run. They kind of just checked it on the graph that what's the slope of each of the opposite sides. So you could do FG. So we do rise over run. What'd you get the slope of FG to be? Can you tell? 5 over 5 or just 1. And then same thing JH if you kind of count that. And again, you could actually use the formula. Kind of starts looking like this little 3-dimensional thing here if I draw it that way. But then don't forget, so those slopes are the same. So these are parallel. But then I still have to check the other ones as well. So I have to check over here. This is down 1 over 2, down 1 over 2. So I can't just check the one side unless I'm using, so it's a -1/2 and a -1/2. Did anyone use anything else? Okay, so the girls up here, they did midpoint. They found the midpoint of each of those. So if my drawing doesn't get too convoluted here, we're trying to find the midpoint of each of those. And they should have the same midpoint. So if we found that midpoint of FH, remember that'd be -3 plus 4 divided by 2, 1 plus 5 divided by 2. But then we also have to check GJ as well. And they better be the same midpoint. Better be. Ends up being 1/2 and then 3, right? Did anyone try anything else? Those are probably the 2 big ones that I would probably suggest doing. So that looks good. I think good on those. All right. So I do need to grab some graph paper for you guys for homework. But what we're going to do for homework is we actually already did the first half. Because again, these notes were like, I must have run out of time in my previous last year. So we're just going to do the second half, but I do need some graph paper, so I will grab that unless anyone has their own graph paper. But I'm just going to grab some off the printer. Yes.